This set of guidelines, utilization of recycled asphalt in cold mixes and cold in-place recycling processes, that was the title that was selected by the steering committee. And when we started scoping out the project, we weren't quite sure if that was the right title, but it was left the same, even though the scope of the project was slightly different. And basically the project was to look at uses of recycled asphalt or recycled asphalt shingles, that type of thing, and not worrying as much about using it as a hot mix, but looking for other uses of it rather than as a hot mix material. So that's the guidelines as they were developed are sort of slightly different scope than the title would suggest. So again, the report starts out with just classification of recycled asphalt wrap. It covers the processing of it, get into things on rejuvenating it if you are going to use it as an asphalt product again, testing that can be done on it, some of the design procedures for using it in a mix again, some of the processes and equipments, and then we get into applications, and this is the area where we look at other applications of using wrap rather than as a mixed material. And then we cover off best practices. The project was identified because of a number of reasons. The big one being that aggregate in the province is becoming scarce. Haul distances are getting high, up to 100 kilometers and so on. And hot mix, old hot mix, has a lot of aggregate in it. It's 95%. And so people were looking at how can that be used. The rising cost of oil, so the oil in your reclaim has a value. It's a mature infrastructure system out there. In the past, a lot of the rehabs on roadways and so on just consisted of an overlay. Now, cities and municipalities and the highway department, they're into second and third rehabilitations. And so there's width issue, there's curb height issues. So just about every paving job these days has some type of reclaim coming out of it. And most of it isn't used back in that project. So there's mounds of reclaim sitting around, whether it's milled or whether it's chunks. So the need was identified, how can that material be used? What's its value? And the next one was there's a lack of well-defined or time-tested procedures on using it for other applications. And then the emerging technologies. RAP has been used for a number of different applications and coming from other areas of the world, and so it was thought that it's worth looking at it to see if those applications would be applicable to Saskatchewan. So again, what's included and what's not included. We tried again not to get it too detailed and too technical, but there's step-by-step reviews of a lot of the processes. We looked at testing requirements and they listed them. We didn't go into a lot of detail in them, but we had references to them. And again, we included a lot of references that have the technical detail in it that's referred to in the report. But there's not a lot of technical detail in the report, but there's a very thorough set of references that are attached to it. So again, today's presentation, it's not going to be technical. I'm going to just touch on the applications and some of the general processes, and I'm just going to hit highlights of each of them. So RAP was the main material we were looking at, but in the initial meetings we talked about RAS, which is recycled asphalt shingles. And since they were becoming an issue in some of the agencies or landfills, things like that, it was thought that we should maybe include that just as a short look at it to see what the applications were. The types of wrap that we're looking at is anything from lumps the size of your table to millings. There's all the questions of blending it, the cold in place recycling materials where you combine the wrap with a bunch of other things, and also whether it can be used as a source of aggregate and whether it can be used as a source of bitumen. So in terms of processing wrap, the two major areas of doing it are an in-place process where it's reworked at the site and basically reused at that site. The other is where it's been already hauled to a central site and you've got the mountains of it and you do a processing of it there, grinding it down, crushing it, whatever you want to do for the application you're going to use. So those are the two main processes that we talk about. The other thing we look at is rejuvenators. Rejuvenator, in our definition, is anything that would be used to soften that material so that it could be used again. We include a list of proprietary products with a little bit of assessment on them, but not a lot of detail about them. And recommendations on developing, again, an interagency shared product list. A lot of the cities and the municipalities and highway department have used a lot of these proprietary materials. Some have worked well, some haven't, but there's not a good source of or way of sharing that information. So if the city of Regina tries something and have real good success with it, or success in some areas and problems in others, the next city of Yorkton or whatever shouldn't have to go through that same thing. They should be able to say, well, yeah, it works here, it doesn't work here, change the processes, whatever. We need to be able to share that kind of information. So the testing relates to testing the gradation of it. So if you're processing this material and going to use it again, you want to know what that gradation is going to be. The binder content, how much asphalt residual material is in there, and what are the properties of that residual material. So those are the main areas of testing that are covered off. As well, later we talk a little bit on mixed designs. So if you talk mixed designs for asphalt reclaim, there are a number of different processes out there. Most of them are the processes that were used for virgin mix, and they've been modified to include reclaim. None of them handle it really well, and there's a number of assumptions about the aging of the old asphalt and whether it'll perform, interact with the new asphalt, and there's a bunch of assumptions, but really no good design method that tests that or proves it. The other issue is with the new super pave design processes, it doesn't fit into super pave. There's been a bunch of work done. They're starting to come out with a new design method now for super pave with higher ratios of wrap in it, and it still has problems, but there is a design procedure available. The other one that's a real problem is now when you've gone away from penetration grade asphalts and you're gone to PG grading, if you start specifying a PG graded asphalt to get the performance for cracking and rutting, and you put wrap into it, what happens to it? And those questions haven't been answered. So the end product is a lot of questions as to how do you use wrap in a mixed design, and will it work? Those same questions apply whether it's a hot mix, a cold mix, whatever. So when we get into the area of processes and equipment, we talk about the central plant operations, and then there's the in-field operations. And so not a whole bunch on central plant operations. Typically, if you have a central plant operation, you'll have a crushed wrap that are a controlled wrap, and so you can control the properties, you run the plant the same way. The in-place recycling, there's a number of different processes, and the terminology, depending on who you talk to, can get confusing in terms of whether it's in-place recycling, whether it's cold in-place recycling, hot in-place recycling, full depth reclamation. Some people use it interchangeable, and even with the steering committee, we got into some discussions. We'd say one thing, and they'd say, well, no, we call it different, and so on. So we had some of those discussions in terms of how do you even refer to it so when somebody picks it up that they get the same meaning out of it. And then, of course, with each one of those, there's a whole variety of equipment that are used to do it. So when we looked at cold or surfacing projects as an application, we concentrated on looking at whether you could use it to produce a cold mix material, something that could be, RAP could be mixed at a stockpile site where the reclaim was and then used maybe as a patching material or as a cold mix that you laid in lanes, whatever. We also looked at the processes and how it would be different for a hot mix as well as warm mixes. With the new warm mix technology, there's not a lot of information about using RAP in a warm mix. So again, that's an area we identify later. So one of the things that we looked at is high RAP ratios. And typically what we found was that if you're going to use a high recycled ratio, that you should probably be using it on a lower volume road or on back alleys or something where it's not going to have that same consistent properties as you'd expect from a normal hot mix. For low RAPs, you can use a low percentage of RAP in just about any mix. It's just a matter then of your risk management. You've got to balance off the potential costs of maybe a little bit less performance or a few problems versus the saving of including that RAP. When we get into the other applications, using RAP as a base, to replace granular base course, or to just mix with a granular base course, basically what the literature says is you can use up to about 30% RAP in your granular base course without affecting the properties, or maybe even improving the properties. If you're looking at full depth reclamation, most of it is up to 100% RAP, but again, it depends on what your underlying structure is. Most of the applications recommend milling an equal thickness or something close to that of granular material into your hot mix. So then you've got about a 50-50 blend, and you've got room to add in rejuvenators, emulsions, other things like that. And then you get into also asphalt treated bases. And RAP can replace an asphalt treated base at fairly high ratios. Just a couple of pictures of applications. We looked at a number of different applications. This is an example from Alaska where they actually used RAP as a gravel material to create a gravel trail. This trail was previously just a gravel walking trail, and they've used RAP on it with great success. Looks good, delineates it, and so on, but no different than using it as a straight gravel. Shoulder base, if any areas where you've got a shoulder treatment on a rural cross section, up to 100% RAP. The first example I know in Saskatchewan where they used RAP on the highway system on the Yellowhead Highway, there was a section where they were milling part of the old lanes and paving part of the new lanes at the same time, and it had shoulder base on it. The contractor proposed running the reclaim from one lane through the plant and laying it as 100% in place of the shoulder base. Went extremely well. Ministry never picked up and used that. They allowed RAP in on shoulders, lower quality mix on the shoulders, but never did put it in their specs to say, yes, that was a good process. But it's still out there performing well. So again, it can be used up to those high ratios in the areas where it's probably not a high risk. And then, so obviously if you can use 100%, any lower percentages than that, you have better control, better application for it, so your risk is reduced. RAP can be used basically anywhere for a fill material. The research shows that it's really not a contaminant. You don't have to worry about things like that. The only thing is that it's pretty high-priced material to be used as fill. And it also can be used in a number of soil stabilizing applications because it has that good characteristics of locking things together and gives you good strength. One of the areas that gets a lot or can get a lot of use is dust control. When you centrally process the RAP, it creates a lot of fines. That fines can then be used on your gravel roads, and it works as a very good dust suppressant. And so you're not only reclaiming all of the aggregate, using it again as aggregate, but you're getting a byproduct that you can use as an application. This is one that requires a lot of looking at, has a lot of potential, is the use of RAP as aggregate for both sealing and slurry sealing. The research is showing, and other jurisdictions around the world are using RAP aggregate as a sealing aggregate for both those processes. As far as I'm aware, it hasn't been tried in the province. And there's also proprietary technology that promotes that use and how to use it and so on. Here's just an example of that. This is in California where they're laying a seal, slurry seal, that's totally RAP aggregate. And again, that gives you something to do with that fine end of your processed material. Most of the places where you go in and centrally crush the RAP, you end up with your aggregate size material that's used, and there's a lot of fines that agencies have been having trouble figuring out what to do with it. Between this and using it for dust control, potentially now all of that material can be used. Some of the other applications, a lot of information in the literature about using it for parking lots where you're not as worried about high-speed traffic, your risk is lower, works great there. Bikeways, walking trails, things like driveways. City of Regina built their training section using RAP, just a big area that they have where they train their equipment operators, laid down a bunch of RAP, performing extremely well. Here's a trail in Richmond, BC with recycled asphalt to build walking trails. You'd never know looking at it that that's not a brand new hot mix. And it all comes down to the economic evaluation. What you're doing is you're trying to get as much value out of that waste product in terms of the asphalt and the aggregate in it, and saving having to use virgin products. So we get into the economic assessment. If you look at things like cold-in-place recycling versus conventional cold mixes, you can get a saving of 20 to 40%. Compared to hot mix, that saving can go up as high as 40 to 50%. One of the numbers we got using 100% RAP as base versus bringing in virgin aggregate, total saving was 18%. If you use 50% RAP blend in your base versus the same virgin base, that saving went down to about 11%. Fill, again, if you're trying to dispose of the fine ends and so on and have no other use for it, great. It depends on your haul distance and so on. It just seemed like too valuable a commodity to be using as a fill material. Things like dust control, you can save up to 50% over conventional products. And using a wrap for something like a driveway, parking lot, you can save up to 50%. So some of the non-economic considerations, and some of these do actually have a significant economic impact, but we don't usually think about them that way, is just the aggregate scarcity. That there's not just the cost now of hauling it, but if we keep using it up the way we are, what's the source going to be in the future? And the other thing we don't think about when we're looking at in-place recycling is in-place recycling, you don't have that haul. So you're not destroying all your other streets and highways and so on, getting the aggregate in there and fixing it because you don't move anything in and out. So spending maybe a little bit extra money to do it in place, you save the damage to all the rest of your infrastructure. The whole issue of sustainability in terms of recycling materials, reducing use, reducing footprint, less interruption of traffic, all of those things are important to the whole process and the decisions. And the whole energy use issue. You're not doing as much haul. That's the biggest saving in terms of impact on the environment and the use of energy. But there are other things about if you're using cold mix versus a warm or a hot mix and so on, you don't have the plant operating costs, things like that. Develop processes that are suitable to our type of materials and so on. One advantage that Saskatchewan has is just about everybody got their asphalt from the same source. So any processes that you use on old asphalts, you're all going to be recycling basically the same material. Whereas in other jurisdictions, their asphalt cements came from just about anywhere, so you never know what they're dealing with. So some of the research that we looked at that probably would be valuable is determining the long-term performance of RAP, just so you can prove that economically you're getting that benefit, that you're recycling the material, but you're still getting the performance you're looking from the roads and so on. And the design mix procedures, using SuperPave with RAP, modifying the Marshall mix design with RAP, and whether RAP can be used with the new warm mix technology that everybody's starting to move into. These are ones that we also felt that would be of keen interest to all of the sponsors and the communities in Saskatchewan, is the use for slurry sealing, because slurry seal aggregate and chip seal aggregate is also difficult to get in the province. There's still a lot of gravel roads and gravel lanes and so on, so dust treatment can be a significant issue. Retaining walls, this isn't as big a one, but RAP makes an extremely good material if you have to build temporary retaining walls. Say you're working on an intersection on a roadway or something, and you need to do a mechanical or earth-stabilized retaining wall. RAP makes a great backfill material. After the job is done, you can salvage it, use it again somewhere. And the last one that's been used quite a bit now is in trench repair. RAP makes a real good material for repairing utility cuts and excavations and so on. So if you're looking at cold mixes, which is where we started out, the whole idea is that you can probably use reclaimed aggregate asphalt mixes that have been pre-processed at anywhere from 0 to 100% and get a product that'll work. All you have to do is make sure that you appreciate where you're putting it, what the risks are. Generally, if you're using it at a low traffic volume operation, your risk is low, the economic benefit's going to be there. One of the issues, and the rutting issue, is related to in-place type processes. that high ratios wraps are a problem with rutting if you put too much fluids in as a rejuvenator. You just can't get rid of that fluids in there, so then you're into additives of cement or lime or fly ash or something to take that fluids out. So that's probably the biggest concern about the in-place processes. So just sort of a range, 0 to 30%. You can use it anywhere with hot mixes. 30 to 100%, your low volume roads, parking lots, driveways, anything like that. 100% patching materials, shoulders, those type of applications. As an aggregate, can be used as a base, sub-base, shoulder base without any major concerns. And there are all kinds of different additives that are available to modify those properties, make it easier to work with, and so on. Most of which are proprietary, but there's a lot of them that are just adding emulsions, standard emulsions, things like that to them. The undersized wrap fraction, again, you can use it as base, sub-base, embankment, fill, stabilizers, dust control, slurry seals, and chip seals. And these are the things that you haven't heard a lot of, or I hadn't heard about, we hadn't seen a lot in the literature up until recently, where there's a lot of central processing of wrap taking place now, and people are starting to look at how do we use that fine end. Just some items on storage. Typically, if you're going to store wrap, you want a large cone-shaped pile. You don't want to put any heavy equipment on it because you end up then with those big lumps that you may have just finished crushing. If possible, cover it because it tends to take on a lot of water, and if you're going to use it for an application where you don't want a lot of fluids in it, you're going to have to dry it. And place it in a paved or on a paved surface works best because then you don't contaminate it when you're picking it up afterwards. And again, we included a bit of a flow chart. And again, this is just an example of the type of thing that can be developed for your own applications that looks at if you've got wrap, where is the best place to use it? And our basic conclusion, I think, was replace the most expensive material you can with it. That's the best value. And that summarizes it.
Let's just jump right into a discussion with Alan here. I just thought of one question. Who all here is recycling? And if you're not, is it an equipment consideration or volume thing? Questions, comments on what you've seen in the report?
I guess I got one question along the same lines. How many of the cities, do you own the wrap when the job's done, or does the contractor own it?
We retain it. The city for Alberta retains
Yeah, so you retain the value of the wrap, you don't give it to your contractors?
We have it in our contracts.
Because that makes a big difference in terms of whether they use it or not. Who owns it?
Now, on your economics slide there, you show the savings for using wrap for servicing. Savings for using this base. What's the comparison in benefit for servicing versus base?
I don't know percentage-wise, but paving, you're probably talking a value of $100 a ton versus something that's down in the $30 to $40 a ton range. So obviously, if you're using, yeah.
Yeah, from industry on our end, we heard from both Valley
The one thing that you can do though is you can look at your whole surfacing design process. And if you're using a reclaimed material, it's probably going to perform more like a black base, and you can reduce the thickness, so maybe use more sub-base and reduce your base requirements, those type of things.
Trying to get it into the actual hot mix, replace tons of that to take advantage of that oil.
Yep.
But the hurdle for us has been kind of an internal thing, is like you said, the quality and whatever. Somebody's always worried about it not meeting a certain standard, put that on the pathways or something.
Elaine's going to solve your problem.
Yeah, I guess when we were reviewing the present state of things with the rock hot mixes, the general consensus was that the roads with the rock hot mix perform well. They do perform well. The truth is that they're just great. It's a risk management. No one wants to put it on a high traffic road and have it fail because then they're saving peanuts, they're not saving anything. So it's a fear factor more than actual performance, because it has been performing well. And in fact, material testing with RAP always consistently shows that it's actually better than aggregate, than virgin aggregate. Another thing about using the binder content is Alan focused a lot on using the fines. And what the deal with fines is that they have a high binder content. That's just the way it crashes, and with those cheap seals, that's why they're so interesting. They're basically taking advantage of the fact that there's so much binder in those fines, and as a result, they have to add less. And so it's a real interesting thing.
Just another comment related to your using it in hot mix. Typically in Saskatchewan, or my experience with highways, is you use as much granular material as you can and try to use as little hot mix as you can. Now, if maybe you should take the approach of more of the perpetual pavement type approach, where you use lots of sub-base, little bit of base, put a thick layer of reclaim that's maybe a 25, 30 millimeter top size, and then put a conventional hot mix on top that you plan on going in and reworking every 10 years, 15 years or something. We haven't really started looking at how that impacts the design, but it certainly addresses all the rutting issues, all those type of things and so on. So.
Other questions, thoughts?
I noted in here for the dust control, and for me this is pretty interesting because of course our council wants to get rid of street oil. It's not popular, and they want to do it for environmental reasons. One of the things that we had done when we first started getting milled asphalt in the city was we had, just to see what we could do with it, we had spread it in one area where we had gravel streets, and then we used the reclamite product with it. And actually, when we first did it, we just used a grater. We wound up with actually really nice surface, but then it crumbled over time, and so we kind of went back to gravel. But the observation that there isn't as much dust from it makes sense to me, because I think in that area, I have to say, we don't have the dust issues quite the same. So maybe with us using it this way may make more sense. But I see that you were saying that calcium chloride should be applied to it as opposed to something like a reclamite or something. Isn't that what
No, I said that if you're in a recycling process, if you're adding, let's say you're adding an emulsion to get it back up, if you're using 50% reclaim from asphalt and 50% base underneath, and you want to put in virgin asphalt, you typically will use an emulsion in a cold process, but the emulsion's got enough liquid or water in it that your then liquid contents are too high, so that you end up adding a cement or a fly ash or a lime to take that moisture out so you can actually compact it. Otherwise, you've got a tender mix.
Okay.
Others? Comments, questions? Arlo, anything you want?
No, I think, well, it's like Alan said, one of the big sort of missing pieces here is the actual design process. How much utilize that's something for future development.
Well, and the mixed design and the other, and we didn't even include it in here, is the whole, how does it fit into your pavement design? And what value do you give it? And can you reduce other thicknesses with it?